Welcome, everyone, and thank you for attending. The AIA Monterey Bay Co-Committee is very excited to present this webinar on Passive House, its principles, and how we can build to the Passive House standard right here on the Central Coast. We still make a huge impact on comfort, indoor air quality, and reduce the impacts of a building's on carbon emissions. This presentation will look at the 5 basic principles and how Passive House principles and how Passive House is applicable here in California using a project located on Pebble Beach's storied 17-mile drive. We will look at specific building assembly details that meet Passive House performance targets for the Monterey Peninsula, as well as the assessment results for the embodied carbon footprint on this specific design. This webinar will be counted towards 1.0 learning units. Questions may be asked in the Q&A or live at 12:45. So back in late January, our committee offered a tour of this house, 17-mile house, while under construction. Those that went on tour wanted to learn more about the project. The builder, Rob Nicely, who's here with us today of Carmel Building and Design, suggested we contact the architect, Bronwyn Barry, to see if she was willing to speak with us about the design, and to our delight, she said yes. Bronwyn Barry is an award-winning architect based in San Francisco, California. She was educated in South Africa, the UK, and the USA, and holds a Bachelor of Arts from the University of Natal, KwaZulu in South Africa. She attended UC Berkeley before apprenticing at various architecture practices throughout the Bay Area before opening her solo practice. During her apprenticeship years, she organized and directed California's first all-women construction crew for Habitat for Humanity before moving on to both Passive House California and the Passive House Network, where she serves as policy director. Ms. Barry's advocacy work extends internationally. She was an active contributor to the UNECE's Coalition on Buildings, working to develop a global standard for high-performance buildings. In 2011, she renamed her design firm Passive House BB and began working exclusively on Passive House projects throughout California and Colorado. Ms. Barry has contributed as a subject matter expert on various research projects led by Lawrence Berkeley National Labs. She consulted with California Codes and Standards to explore a multifamily passive house reach code for California for the 2019 code cycle. Her firm received the highest merit award for the 2021-22 Architecture at Zero design competition for an affordable multifamily passive house development located in California's Central Valley. In her spare time, Ms. Barry is an avid reader and collector of recipe books. She is an aspiring gardener and baker of, as she says, inedible bread. She rides an e-bike around San Francisco and attends dance classes at ODC. This lecture is one of a series of webinars the AIA Monterey Bay Co-Committee has organized around the Healthy Materials Pledge. Today's lecture on Passive House touches all categories, but fits particularly well within the ecosystem health category. The Architecture and Design Materials Pledge was developed to inspire a shift in how we evaluate the products and finishes that we specify on a daily basis. Participants commit to 5 overarching statements that will lead to more intentional product specification around their portfolios over time. So I'm going to put a link to this in the chat. And so check it out and see if your firm wants to be a participant. I'll now turn the lecture over to Bronwyn.
Thank you, Libby. Can everybody see my screen now? Great. All right. Well, I'm really delighted to be here and honored to be invited to share this project with you. I'm going to jump right into it because I have lots of slides, and I'm happy to also have Rob Nicely here from Carmel Builders to contribute. So Just a quick addition to the introduction to give people some context. I really started exploring Passive House back in 2007, where I came across it here in Berkeley with another architect returning from a sojourn in Austria, renovating his house bungalow in Berkeley, and really kind of dove in feet first. I started out sort of tentatively and then worked with a builder for a number of years here in the Bay Area. And we collaborated as a design build team. I basically subcontracted my design services for his construction company. And we did a bunch of really interesting projects. These are three of them. The first retrofit back in 2011, and then a couple of new builds, sort of semi-retrofits. I've done window design, supporting a window manufacturer to try and get a profile certified. And I've really been segueing into policy, trying to connect the practitioner world with the policy world, because we see, I've seen so much sort of disconnect in that in my day job. As Livy mentioned, I was honored to receive the highest award for the Architecture at Zero competition. I encourage you guys to participate. I learned an amazing amount doing this prefab passive house straw panel multifamily, affordable multifamily subdivision. Was based in the Central Valley of Visalia. Lots to do there. And I've been trying to segue my firm into doing more of these low-rise multifamily. This is a speculative project, 4-story, 4-unit to 6-unit, 2 to 3-story homes that fit into standard single-family homes neighborhood. This is literally a street I'm working on in Sacramento, showing what that would really look like next to a home that we typically see in our suburban subdivisions. But I'm here to talk about this particular project, 17 Mile House, and I'm going to cover a brief sort of review of the design evolution, because I think as architects we always want to know those things. Then I'm going to dive into the details, the assemblies. Then I'm going to look at the performance metrics, including the pH ribbon, the embodied carbon calculation analysis that we did on this project, and close with the lessons learned. So before I start though, none of this stuff happens without a team. And I really want to acknowledge, firstly, Rob, who brought me into this project. He was the prime. The client met with him first, and his team has been really exceptional to work with. I've really enjoyed working with Matt, Eddie Ortiz, the site super, and Michelle Sturbeck, who's really supported a lot of the interior finish detailing and interior design work. All the engineering teams we work with, Rasmussen, Arnold Engineering, and Landset. And then the energy modeling team, Steve Mann is the certifier on this project, but also did the Title 24. Andrew Mitchler, a colleague of mine, did mechanical design support. Vlad Petzel did embodied carbon, beg your pardon, Steve Mann did the embodied carbon and Vlad did the thermal bridge analysis, and then myself as the architect design lead. So it always takes a team. All right, so let's jump right into the design direction. These were the images my client came to me with, saying, what she wanted for this project was sort of a modern style, natural materials that fit into the landscape. So this was sort of the direction she was wanting me to head in. And then we looked at the site, And the image on the left is a photo from the actual property, taken before we did anything. And I really, really fed off of these amazing trees. It was a very wooded lot, very particular tall pines, and then these very horizontal oaks, which sort of all grew very like horizontally because of the nature of the soil, a very thin soil and high water table. And then you all are familiar with the beauty of the Monterey Peninsula. This is a photograph I took um, along the boardwalk in front of a Sillibar. You see the spectacular, the verticality of these rocks, the horizontality of that coast sea horizon. I was really riffing off of those. And then, of course, the incredible richness of the architectural history of the Monterey region. These were all images I looked at and was inspired by. I don't need to go into the details of this, but you see the strong roof lines, the natural materials, the really simple palette, and the really bold forms. And as I went into sort of sketching, these are some of my really rough schematics, looking at sort of how to integrate the program into the site between the trees, which meant really breaking up the forms to fit into that, within the existing tree canopy. And you can see this is sort of where I started to add in those angles, riffing off of that modernist, angularity. And as I went sort of vertical to find the form, um, continued with that sort of triangulation, those asymmetrical roof lines. Really, you could see the where I kind of sourced that form from. And then as I developed sort of early concept designs, I had this sort of moody, broody roof that came over the front. This is the street elevation, the north side. So it was also sort of a privacy, keeping the public's view out because we didn't want to build big fences and walls. The direction from the client was to keep things open and natural. And you can see client didn't really love the moody, broody roof. So I looked at like how to make different roof forms. She liked the strong, linear, like flat look. And these were sort of versions that we started looking at. Then I started looking at finishes, material selections, and you could see there were a few iterations. I looked at sort of more complicated detailing around those window openings, which we rejected for just being too complex. And we settled on a palette that was also driven largely by the WUI requirements. This project is in the wildland urban interface, so all of our materials had to also comply with WUI regulations. So, but you can see very natural palette, very muted tones, with some nice textural qualities, starting with the split face CMU foundation, some gorgeous windows, and then just very simple cedar siding, and then the standing seam metal roof with an accent in the Shoshugaban, the charred wood at the entry. And this was sort of what evolved and has kind of become what you see on site, with the rear of the building having a slight different material change, both for cost effectiveness. We didn't cedar is expensive, so wrapping it around the whole building got really pricey. And also for fire resilience, the back side of the house backs onto an open space parkway, which we think is sort of where a fire would typically sort of emerge and run down. So we wanted to add some additional fire resilience to the rear. And that was originally designed as standing seam metal. And you'll hear why it reverted to being hardy fiber cement paneling, which we painted to match the cedar. Floor plan, very modest floor plan for this property. The homeowner was not interested in a large home. We could have gone up to 20,000 square foot house on this 1.25 acre lot, but we kept it at a 3-bed, 3.5 bath home, which is just under 3,000 square foot for the primary building. And then we have a small studio and a detached 2-car garage. So as I say, quite a modest footprint for this location, and a very efficient floor plan. And this is a fairly recent picture. It's taken quite a couple, I mean, almost 6 months ago, just to sort of give you a sense of like how the project's evolving. With the siding going up here, this gorgeous cedar siding, and a very intentional trim detailing that also just kind of gave it some design interest, but was very intentional to also create a stop for the vertical siding pieces, so there were no weird exposed butt joints. And the interior is also really simple natural materials palette. You can see lower right is the kitchen, a nice textured backsplash tile, a countertop in a really lovely sort of veined countertop material. It's the faux one. Say that again, Ron.
Quartzite.
Quartzite, thank you. Oak, lots of oak cabinetry, oak flooring, and a slate tile floor. So the spaces are really pretty interesting and dynamic because of the rather dramatic roof line, but really beautifully finished on the inside. So I'm going to dig into the details here, because this is where the meat of the matter really happens in architecture, where you peel back the onion. So starting with the basic passive house principles, for those of you not familiar with passive house, it's effectively five features made climate specific, and you kind of dial that all in using the energy modeling software. And the features are super insulated walls and roof floor, all the assemblies, usually a little more beefy than standard. Super windows. We did use triple pane windows in this project, although we could have easily got away with double pane. The reason I went with the triple pane was because they were made in Kansas, and the cost of them was minimal, if not on par with the double. And we get so many performance benefits and also acoustic benefits from the triple. And given that this house is on a fairly busy part of 17 Mile Drive, acoustics played a big part in that, helping make that selection. We have a super ventilation system, which I'll dig into a little further to elaborate on that. And the whole building is what I call smoke tight. So we did all the airtightness and smoke tight assemblies, and we carefully considered all the thermal bridges. So those are the basic passive house principles. And here's how we applied them. So this is a sort of a collage of my basic building section with all the details. And really what I'm trying to highlight here is the red line. The red line is the connection of all the details for my airtightness, what I'm calling my smoke tight layer. And this particular building got really interesting because of the roof design, and I'll go into that more in more detail. But really, I like to do a big section detail most of my plan sets. My details look very similar to this, and then I'll annotate them. But I like to show how they all connect and join together because this is something I think we as a profession have massive agency in, and we get to control this as architects. So making sure they all connect and work together is a core architectural responsibility. So in this design, what I really found was core driving the choice of where I put the airtight barrier was my roof design. And I'm highlighting the front overhang, but it was the rear overhang that really drove this detail. And if we zoom in here, you can see I have my standard roof rafters, which were 9.5-inch TJIs, and I ran them long and projecting through and over the wall, which is very atypical for all of my passive house designs. Mostly what I end up doing is I clip the rafters at the plywood and then add overframing to give me my overhangs. But because on the rear of this house, I wanted an 8-foot long overhang, that was a very long cantilever for overframing. And it would also mean air sealing around each and every one of those rafter tails would be really time consuming and potentially dangerous up at the second floor for the construction crew. So I elected to bring the air barrier to the inside because of these rafter tail and my deep overhang. And as it turned out, it worked out better for a bunch of other reasons on this particular design. So it's something that I would highly recommend for your particular climate. And we'll get into why that is in a little bit. So this was my first interior air barrier, which is pretty classic passive house, but not typical for California. So the second detail that was really pretty revealing was this floor to wall, that the second floor to wall intersection. And as you see it a little bit more enlarged, the tricky part with that, with having an interior air barrier, is getting this continuation around the floor joist. So you stack the first wall and then you platform frame the floor joist on it, and the second floor wall gets framed above that. But to do this interior air barrier, I had to get the crew to be able to put a membrane flap over the top wall, stack the floor joists, flip the membrane up, and then bring it to the inside. So it was just a little bit of a new detail there. Plus, this detail got really interesting in the thermal bridge analysis, and I'll cover that a little later. But just remember this detail because I had put insulation here in the joist cavity, but learned something really interesting in the thermal bridge analysis. And just to sort of recap a little bit, passive house for a very simple form factor building in your climate is a 2x6 wall. That's it, with dense pack cellulose insulation. I have to say I was shocked by how easy this is and how pretty much it's kind of code compliant. But I would also emphasize it was really primarily also because I had a very simple building form. The more complex, and it was 2 stories, so it was compact, had great form factor. But the more jogs and protrusions, the more elongated the shape. probably the more insulation you will need. So it became very cost effective and not complicated. And as you can see from the site picture here, the internal furring strips allowed all the services to be installed. The electrical, you can see the junction box is inside of the air barrier. So there weren't too many pokes and penetrations of that air barrier, although they did staple a few things, wires into it, which I was like, but generally they did a very good job of the air sealing because they had this internal layer they could utilize. Then down at the foundation, we had a very simple foundation as well. We did the insulation at the floor joists, which allowed us to do the exposed CMU stem walls. We have very little concrete in this home for two reasons. We did the cantilever, reduced the footing size, but we also just used these CMUs stacked on the spread footing. And Rob came up with a really smart detail of just doing compacted pea gravel instead of a rat slab. So a sealed crawl space, uninsulated, and very simple. And on the left, you can see the CMU and the cantilever at the sort of tight corner. So the thermal bridging, we really didn't find any big surprises. We did the roof to wall, we did the wall to foundation, we did the cantilever, and where we found an interesting potential condensation point was at this floor to wall assembly, where the modeling revealed that we could have potential condensation happening inside the floor joist here. And the mitigation sort of that we discovered from having this analysis done was we simply just needed to add a little deeper insulation in this floor cavity to prevent that interior condensation. And I would tell you guys, this is critical for your climate because you have such a foggy summer. The client told me the story about when she was looking for properties. She went into some very fancy homes that were reeked with mildew and mold. And I think climate, really looking at these details very carefully is very critical in your climate because it's not too forgiving in terms of mold and mildew. Another detail, this is our ventilation system. It's carefully integrated into the architecture. I had this nice hallway soffit over the bridge, very carefully detailing just to make sure that we could distribute fresh air to all the rooms that required constant fresh air, and we can extract all the stale air from the bathrooms. We use the Brink system. It's installed now in that upper utility room. And I'm looking forward to hearing and seeing the data on this pretty new to the US market unit. This is where I'm going to break and let Rob weigh in and tell his version of this project story. So Rob,
thanks, Bronwyn. Yeah, I don't want to take up too much time. I'll just, I guess the theme that I want to reinforce is that, like Bronwyn was saying, in our climate, it's what we have to do to reach these performance levels are not that different than typical construction method. I would say that the difference is that you have to begin with the end in mind in terms of the performance level. So Bronwyn was talking about our pressure boundary, that interior air barrier, which is where the definition of the edge of the conditioned space. We did have to, at the floor ceiling assembly, the second floor, you do have to, as you're going along, make sure that you're putting the pieces of the membrane that's going to be the pressure boundary in place when you're at the right point during construction. So that's at the floor ceiling assembly, and then also at partitions. So where an exterior wall meets an interior wall, when you're making that assembly, you have to put the membrane behind it so you have something to attach to, so that really Bronwyn talked about the red line in the sections, and that is critically important to us. We have to, when we get the plan set, we think about how are we going to make sure that we actually know how we're going to connect all the parts of the air barrier, so that we don't run into any place where there's a gap that we can't make that continuous and coherent. I'll also mention that Bronwyn noted that that a regular 2x6 wall with good insulation was good enough to reach the level of performance we're looking for. In this house, we did have additional rigid insulation outside of the frame cavity on both the roof and the floor. So we did have a little bit of exterior insulation, and I'll just tell you that I love exterior insulation because Bronwyn is referring to the thermal bridging, which is not something that we necessarily thought a lot about in the past before we started learning about Passive House. But when your thermal exterior insulation is great at reducing the impact of the normal thermal bridges, which are just like any place where there's wood instead of insulation, you have a little bit of a thermal bridge, right? Insulation is insulation because it works better than wood. So if you do have exterior insulation, and I've done other Passive House projects further out the valley where we had a bigger temperature differential where we had to beef up the assemblies, and it just makes life a lot easier. And so for me, the real challenge is I at some point knew enough about this to understand what I was supposed to do. But a big part of actually implementing is finding the resources to do it. So finding the various materials that maybe aren't at the local lumber yard. Although with Hayward Lumber here, we have an advocate in Hayward, and that they will carry more advanced products that help us. So if with failing that, what you have to do is go out and buy the stuff wherever it is, which a lot of time is in Europe or on the East Coast. So it's a little harder to source things. And then actually recruiting the crew that, some of these things are non-standard. And again, when you're like trying to preserve the air barrier, everyone has to do their very best not to stick holes in it. So one of the things that, with our service cavity there, what we did right away, me and Eddie and Jeff, is we identified every place where we were going to have to penetrate, where the wires were going to come in from outside, where the places where the plumbing had to go from the conditioned space to outside the conditioned space. And we strategized in the beginning to minimize the number of locations where that would happen, so it would be as easy as possible to air seal in the places where we did have to penetrate the air barrier. So Bronwyn, I think I can see one staple in that picture where the electrician through the air barrier. That's the kind of thing that you have to, again, with having the end in mind, those are the kinds of things that you have to start being aware of as you're going along and sort of policing the job site. But the biggest thing is finding all the subcontractors and getting people up to speed or finding people that know how to do this. And frankly, it's largely a matter of finding people who are willing and capable, and then getting them up to speed on what the exact outcomes we're looking for. But beyond that, this is not complicated to do. It's building this way is just better in all kinds of different ways. It not only affects the energy efficiency, but also the indoor air quality. The comfort level is amazing when the temperature is the same everywhere in the building, which these things are modeled, part of the modeling is to create the conditions where the air temperature will be the same upstairs as it is downstairs, close to windows and in the middle of the room. And the feeling that you get from that is much different than the feeling of being in a normal building. And then also the durability of the building, because the same thing that produces good energy efficiency is also creating the right conditions where the building is going to be subject to moisture penetration from unregulated places, when air is moving through assemblies, which we air seal in these kinds of buildings to keep the air from moving through assemblies. But when the air is moving through assemblies, a lot of times it's reaching dew point and condensing out, and that's when you're starting to get that musty smell that is so ubiquitous around our area and that we so don't want. And that goes away when you build like this. So you get all kinds of benefits, and looking through the lens of being a tradesman, it's just not that hard. But it is a matter of getting educated and understanding what your objective is. So that's all I had to add. Thanks.
Thank you, Rob. So getting back into what does that really mean, passive house in Monterey on 17 Mile Drive? And you can see I put the effective assembly R values here, R19 in the walls, R36 in the roof, and R32 in the floor. So probably a bit more for floor than what you're used to seeing. And that was really primarily just because we had the depth of the floor joists and we just filled them. And then we added a bit of exterior insulation just because we do have an uninsulated, unventilated raised floor assembly. Triple pane windows, as I mentioned, the 0.13 U value, U factor for those. Didn't need them for passive house, but we bought them because they were just the same price, fantastically awesome, and made in Kansas. So we didn't even have to import them, which was great. HVAC, it's all electric, very low heating and cooling loads, ridiculously low, in fact. Ventilation system has a MERV 13 filter. It's balanced. It's 91% recovery efficiency, so super effective. And we have a Mitsubishi heat pump. It's ducted. You saw the ducting for it. Rheem heat pump water heater. Actually, we don't have the Rheem. We put in the Sandon heat pump water heater, so I should check that. And we have an on-demand recirc pump for the water heating. This is our current verification page for our passive house numbers. We are on target. We will very likely become a passive house plus because we did add additional solar beyond what's required. Just to look at our Title 24, it says we have an EDR of 1.2. I have yet to understand what the hell that actually means, but apparently it's good. The heating loads are very different through the calculations in a KTDV per square foot number. This is modeled is exactly as designed. So very different sort of outputs, very different metrics. No airtight testing required, no condensation risk required, no penalty still for fossil fuels. And my beef with Title 24, I'm quite candid about this. The metrics they use are not measurable. I have yet to find a KTDV per square foot year measuring device. So I've been advocating at the policy level for the Energy Commission to give us metrics we can measure. So, soapbox over. Thank you, Selena. We'll get through this. So I want to dive into the material impact. We did do an embodied carbon analysis using a new plugin for PHPP called PH Ribbon. And this gave us some real insight into what materials matter. I have done a whole extensive presentation on this, which I will point you guys to here on the Passive House Network pH ribbon tab. But you can see on the left here, we did an as designed, an improved design version, a code built version, and an as designed without PV. And I'll show you, the tool gives a heat map for the materials showing the less benign stuff in pink and the stuff that really has a high material impact in dark red. And we can see the cold form steel from the siding was higher than we expected. The roof metal cladding is on the pink list. Foundation, of course, everybody knows concrete is one of the highest ones. And our glazing, because of our triple glazing, was also high. But the surprise that we, and then these were we switched out these higher ones for lower because of this analysis. So we were able to figure out what was better. The big surprise was our PV. I had not done this before, but we found that our PV panels have a very high embodied carbon footprint, which is not to say we do not support adding PV. We are very in favor of that, or I am, and as is Passive House. But it sort of went to having less of everything is really what we should be aiming for, because it's all about balance. And the more insulation you can have, benign insulation, the less PV you need. So it's a great way to think about offsetting your embodied carbon footprint by reducing your overall loads. We looked at all the operational use stuff, the different heating fuels. We know that the grid will eventually decarbonize, and we also looked at what did that mean. So we ran some different scenarios for a grid decarbonizing faster, and whether that's still justified doing efficiency measures. And we could see that over time, if the grid decarbonized by 2035, it didn't make a huge impact on our overall embodied carbon footprint, whether it decarbonized by 2035 or 2050. And that's just specific to this particular design. We were using localized grid factors. The tool does allow us to pick the California CAMEX WECC grid. So it's very localized and specific. And this is sort of showing the decarbonization rates from the 2035 grid to the 2050 grid. So really interesting tool, giving us lots of opportunity to crunch numbers and look at things from all different directions. The all electric scenario summary, this was where our code built and our Passive House built scenarios were very on par. And we ran this scenario with a no PV for obvious reasons, just because we wanted to look at what that did. But really, the scenario that we built, which includes PV, the lowest embodied carbon footprint was the one that we actually did build. And we see, if we look at this in comparison to the REBA targets, so these are the Carbon Leadership Forum didn't have residential sort of benchmarking at the time. Our building is way under half of what a domestic residential embodied carbon footprint is targeting. So we know we've done a really bang up job of minimizing as much as we can. So I'm going to close. I know we're at quarter of, and I wanted to have time for questions. Quick lessons learned. I have to say, the rear doors on this project, you can see them in this photograph here. We went big. I have to say, and that was my fault. They look spectacular. I'm a little worried about them. That's just a lot of glass, and the hardware is going to be working extra hard to hold those things over time. So I would sort of say, probably wouldn't do that again, even though, as I say, they look amazing. I really did learn a lot about doing the interior air barrier, and I think excellent strategy for your climate, particularly. Rob and his team might have a different perspective on that because you've done both ways, but it really keeps the moisture from getting into the wall, which in your humid, moist, foggy climate, the air barrier is where it really should be. Lots to learn about thermal bridging analysis. It's not something any of us typically do. If you're getting a Passive House certified project, you have to do it. And I was surprised at how helpful that was and actually how necessary. Lastly, embodied carbon calcs. This was our first foray into doing that using the pH ribbon tool. It was very helpful. We did have to take a bunch of proxies for different materials because not all our materials have LCAs. I'm very keen to continue down that route, but I would say it's probably not fully market ready for single family homes. And then my last insight was I was shocked by the embodied carbon footprint of PV. It was something I hadn't ever considered. But it really was an affirmation that why we do efficiency first, because we can add plenty of solar panels, but they also carry a heavy carbon footprint. So the last one, I'm showing pictures on the left. You guys all were living through the storm that was early this year, the winter. 2 big trees fell on this property and one of them hit the roof. It didn't cause any structural damage, but it was about 40 grand in cosmetic damage. So Rob and his team are fixing that. But yeah, we were given a real reality check about the impact of climate change, even on this project. So I'm going to close with some resources. We are opening this house for tour. It should be almost finished, if not finished. June 30th, 10 a.m. to 4 p.m. part of the International Passive House Open Days. Please click on the Passive House Network or the Passive House California websites. The links are on the left here. So local California Passive House, National Passive House info at Passive House Network, International Passive House information at the Passive House Institute, passivehouse.com. Lots of good trainings. So everybody can learn how to do this. And as an architect who's really embraced this, it's been a most fabulous journey. I learned something on every project. I deepened my building science knowledge, and I am very comfortable knowing that my clients get a project that will always work for them, and they'll always have great indoor air quality and be comfortable. And that, as a practitioner, is my standard of care that I really am super happy to be confident in delivering. There is a discount for training offered by Passive House California. And we just got an announcement last week that Energy Smart Homes is now offering a rebate, $1,000 incentive for Passive House certified projects, a single family. This is a multifamily one. So close with a couple of recents, just to kind of some eye candy, I hope. And then I'd love to hear some questions. Phew, I think a few more minutes left, right? 8 minutes, we've got time.
Thank you so much, Bronwyn. That was really inspiring. We're getting really nice compliments in the chat. I'm gonna open up, I'm gonna ask Selena and Rob to maybe read any questions that are outstanding, or people are also welcome to ask live.
I've answered a few in the chat. Charlie has one outstanding question, and it's looping back to when Bronwyn mentioned that we switched the wall finish on the back from the standing seam roof to the hardy panel siding, and he's asking, was that due to fire or embodied carbon or something else? And that's a decision we made due to the embodied carbon. We found that we were doing this analysis, and like Bronwyn said, it's the first time we've done it. And I'll just add that I was super excited that this was available to do and that we got to have a chance, because as I've been learning about, sustainable building, most of what you learn is focused on the operational carbon of the building. So to start to be able to dip into and start to understand embodied carbon is just very exciting for me. And I'm so glad that we are starting to be able to do that. But by the time we had that data, we may have switched to dual pane if we could have done it, if the data had come in early enough, but we couldn't, it was too late for that. But something we still were able to do was switch from the metal on the back of the house to the hardy panel, and that drove down the embodied carbon of the project somewhat.
Bronwyn, I had a question. How did you work with the Title 24 consultant? Were there some specific things you requested them based on the passive house requirements? What was your interaction with them?
So I'd worked with Steve Mann. He was the Title 24 consultant for many years. And actually, mostly Title 24 is just an easy, it's like 100% I'm going to pass because I'm doing passive house. So honestly, he does the Title 24. He sort of figured out an export. He'll do the passive house model. He'll export all the areas and the windows for his Title 24 stuff and just input the Title 24 stuff. But for the most part, we literally just get the thing done and ignore it, because it never gives me any information that I find useful. And probably sounds a bit harsh. I really do support the principles of what Title 24 was designed to do. I just find it frustratingly opaque. So yeah, I never really worry about my Title 24. I never have any trouble complying because I'm always usually well above it. So
I think something else that might be interesting to talk about, Bronwyn, is the place where Title 24 doesn't account for some of the stuff that happens in passive house, like air tightness as an example.
And I have that in my slide that I sort of pointed out that, unfortunately, there's lots of things that passive house does, and this is the slide. So we literally are not required. We're one of the few states left in the US that doesn't require a blower door test. And I'm shocked by that, particularly given our smoke events, because you're basically allowing all of that gunk to come in through all of the holes in your walls and around your windows, all that stuff, those places that aren't sealed because nobody's required to test them. So that is a real kind of issue. I've been working to see if we can get the CEC to actually just require blower door test to verify that it meets the code, not passive house, just the code. They're considering it, but there's big pushback from the production builders. Of course, you don't want to do that. And as I mentioned, no condensation risk assessment. This is a big problem. We're building all these buildings. We're putting thermal bridges in them willy-nilly. I was putting a thermal bridge in this design. I wouldn't have caught it unless we had the analysis. So I think this is something that the Passive House community can really help lead on, to build capacity and to build, you know, just a general like awareness of what that is, and to help really push the envelope, literally, and get mold and mildew out of our buildings.
That's
Yeah.
great, Bronwyn. Thank you. Again, really, we are so appreciative of you spending time with us this hour. I'm going to just share my screen and just end with a couple things that we're doing here in Monterey and California. So again, thank you all for participating. Oh, wait, sorry. Okay. Thank you all for participating. I have Bronwyn's address up here. She's shared her Passive House website as well, not hers, but the Passive House website. And this is her business website. If you're interested in becoming a COPE member, we'd love to have you. Selena and I are both co-chairs, and we welcome more people to help us with programming and advocacy. And finally, just a couple resources. As Bronwyn had said, there's going to be on Sunday, June 30th, this Passive House Open Days. So this house will be available to see on the tour. And then AIA California has a host of resources that are online. And as a member of the AIA California Resiliency Committee, we and other committees write these What You Can Do Now series. So this is great for both you and client. They're kind of 1 or 2 pagers. And it really gives a lot of information in those 2 pages. So I recommend you going to the AIA California website, checking out the What You Can Do Now series. Does anyone have any last questions? Okay. All right. Thank you again, and look for Charmaine's wonderful evites for future programs. Next month, we're also having a tour of the Kresge College at UC Santa Cruz. It's a mass timber project done by Studio Gang. And afterwards, there'll be a happy hour here at the Workbench offices. So I hope all of you can attend. Thank you again.
Thank you.
Bye-bye.
Bye.